This is the fourth and final video of the Titanic notebook. In this video, we'll be working with machine learning. So we'll be building some very quick machine learning models and using our clean data set. So a quick reminder, we clean the data set up so it looks like this now. It's all numbers. And we can quickly pass that into some off-the-shelf machine learning models to predict whether the passengers survived or not. So to begin, we're going to be basically we're going to be dropping the survive column on the training set because that's the column that we're going to be predicting. So we don't want that on there. So we're going to drop that. And then we are going to basically clean this up and get it into a format that we can pass into our model. So just so I know, we're going to basically be making the X emission. This is for Kaggle. I won't really talk about this, but this is if you want to read through it, you can submit this data set on Kaggle if you want. Let's print the shape so we can get an idea of what we're working with. We have 891 rows in our training set, and then we have our Y, which is our predicting value in our training set, also has 891. So that's good, perfect. Next, we're going to be breaking into a validation set. So you might remember that we have a training set and we have a test set. What we can also do is take our training set and break that into a training set and a validation set. And this allows us to build multiple models using the same training set, because we're going to use a training set. We're going to use the training set, build the model. We're going to test on the validation set. If that is not super good, we're going to go back, use the training set again, then test on a validation set. So we can keep on going back and forth and testing different models with our validation set without ever touching or corrupting our test set. So then we've taken our training set, which is our 891, and now we're going to break that into our training set again, which is our 712 here, and then we have our validation set, which is our 179 here. And again, we use our Scikit-Learn, this test train test split method here. Okay, so the workflow for Scikit-Learn. This is an overview. You're going to instantiate the model. That's one line here. Then you're going to fit the model. That's the next line here. Dot fit. Then we're going to predict and evaluate. So that's the dot predict. And then there's some. The evaluate is usually dot score, or you can even you build your own way to get the accuracy of the model. So very quickly, the logistic regression, we're going to fit, predict, and then we're going to build the model out here. And then there's different ways. Fit, predict, and then we're going to score the model. There's different ways to get the accuracy. This is just the homemade version, but we can check that it's the same as the dot score method here, and we get a 77.65, about 78% accuracy with the logistic regression. Next, we're going to use the k nearest neighbor, which is the same dot fit, and then we can do dot score here. We can get a 79%. The SVM, support vector machine, we do the same thing. We get 83%, and so on. So we can run all these different models by just using a very consistent interface where we substantiate it, then we fit, then we do the score. And we're always doing the score on the validation set. That's an important note to do because you don't want to do it on the training set because that's data that's already seen before, and you don't want to do it on the test set because then you effectively use up your test set and it's gone. So always do on the validation set. So we're building all these models on our validation set here. And then one important note is our random forest. So the random forest is great because it can actually give us an insight into how important these features are. So if you remember, random forest is going to split on certain features, and more important features, might be higher up splits in the tree. So for example, here we have, for example, the age class. That's a very important split. So that one is saying that this is high importance. And same with the Mr. and Miss titles here. And then these like where they departed from is less important. So this is a good kind of quantitative way to get a picture of what variables are most important in our model. So that's it for basic models. You can see that our highest accuracy was in fact, let's see, it was the SVM, but it was close, right? We saw that the the perception, the XGBoost, and the forest, SVM, they were all pretty similar. So you could say that our model was around low 80s. You can follow this if you want to submit on Kaggle as well. It basically allows us to export this as a CSV with the passenger ID and then their survival as basically a two-column basically CSV file that we can upload there, and it can give us a score. And that's it for our model. Here's some appendix I'll walk through. And you might wonder why our models are maxing out around 80%, right? We had all around 80s here. And here, there's some outliers. This is just a little quick antidotes. I'm not going to go through it all, but essentially there was a guy who was really wealthy here, but he passed away. So that's, the model predicts that a wealthy person would survive. So like, what was going on there? And this is another person. He was a poor person. He was a third class, but he did survive. He was able to swim to some ship and then survive by getting onto this like waterlogged collapsible boat. So it's interesting. There's outliers. See, people didn't exactly conform to what our model predicted. And the takeaway here is that you can't always build a perfect model. These are people, right? They're people doing things and people trying to survive. So there's always going to be outliers to that. And it's when you work with any type of data set that's predicting survival or predicting anything about people, there's always outliers, and you can't usually build a perfect model that encapsulates everything that's going on. So that's just the engineering takeaway here, is that we can try our best engineers, but we can never be 100% building a model that predicts the future exactly. And then there's some appendix here that has some additional notes. So if you want to take a look at a little bit more about these various models, you can read about them at the links provided here. And that's it for the Titanic notebook. There's a Titanic homework as well, so you can get some more experience and practice using these various models that we talked about here.